Yeah, be rolling through the numbers, counting every step, equations in the air like a beat, now we prep. Sebastian on the track, yeah, he knows the grind. Mathematics in his mind, no limits, just unwind. Digits dance around, so precise, so clean. In the world of math, he reigns supreme. We're taking over with the power of numbers. Sebastian Simon, yeah, he's got that thunder. Confidence is key, watch us break these walls. In the math game, we stand, we won't fall. Hey. From algebra to cow, watch him break it down. Grasp the theories here, wearing knowledge like a crown. Sebastian's on a mission, ain't no problem too tough. In this math game, he's the one who's got the stuff. Riding high on numbers, feel the vibe ignite. With every calculation, shining so bright. We're taking over with the power of numbers. Sebastian Simon, yeah, he's got that thunder. Confidence is key, watch us break these walls. In the math game, we stand, we won't fall. So when you hear the beat, remember the name. Sebastian Simon, destined for fame. So when you hear the beat, remember the name. Sebastian Simon, destined for fame. Hey.
Welcome to class. So, today we're going to be learning about the Pythagorean Theorem and what it is. Okay. So for this, okay. So, I need a couple of numbers. So, for those numbers, I'm going to leave them up to you to comment what numbers I should do. Okay, before we get to the numbers part. So, we're going to test this on one of the triangles. So we're going to test them on this triangle. So, this leg, one color. Okay, so this, okay, so the two legs are going to be legs A and B. It doesn't matter what order you put them on. If it says, well, this one 6, this one 10, this one 8. You could do 6 squared plus 8 squared or 8 squared plus 6. It doesn't matter. So, those two are both legs. It doesn't matter what order you do them in. This one is known as a hypotenuse. So, okay. So the formula will be wait, that's not it. Okay, so here's the formula. A squared plus b squared is c squared. So we're going to use this formula to identify the 5 triangles that we're going to be working on together. So I'm going to need some numbers. And you have 1 minute to comment the numbers. Okay, so if you said 2, okay, not 2, 3, 4, and 5, and that's what we're going to be doing. So, A is 4, B is 3, C is 5. If you want, you could flip the 3 and 4, but it's totally up to you to decide. So, I'm not knowing. Down. So we're going to use this formula here to find the area, to find the hypotenuse. Okay. So 3 squared plus 4 squared equals c squared. Like 5 squared. Well, some of you have done this before, some of you have not, and that's why I'm teaching you here. So, 3 squared plus 4 squared is 5 squared. So, 3 squared is 3 times 3. So, 3 times 3 is 9. So, 3 squared is 9. Okay, 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5. I think you all know what 5 times 5 is. What's 5 times 5? 25. So, I'm going to put 25 here. 9 plus 16 should be 25. 25 equals 25. It is true. So, if you did this with 6, 8, and 10, okay, I'm just gonna show you on this one. So you have 6, 8, 10. So, speaking of which, you all probably should know this by now. We're going to use this formula again right here. So we know what to do now. So 6 squared plus 8 squared is equal to 10 squared. And we're testing that. So 6 squared is 36 plus 8 squared, which is 64. 10 squared is 100. So 36 plus 64 should be equal to 100. So 36 plus 64 would be 100 equals 100. If that's about what's the same, it's done. So we could test this through angles. We could test this. 3 more triangles. We need some numbers. Other than 3, 4, and 5. I'll give you 30 seconds to choose. Okay, so I'm not going to judge on the numbers, but if you said 1, 2, 7, and 8, wait, that's 4, sorry, 1, 2, and 7, if you said those 3 numbers that I just said, 1, 2, 7, then we're going to test it. So, this is going to be 1, 2, 7. We're still using this Pythagorean theorem theory. Yes, and I'll have a video to show you, and I'll teach you the basics of the Pythagorean theorem. So we're gonna test if this is true. So 1 squared plus 2 squared is equal to 7 squared. I do not think that's true, but we're gonna test that. 1 plus 4 equals 49. Yeah, that's not near true. So 5 is not equal to 49. 1, 2. So this will be the square root of 5. And you probably realize in my short that the square root of 5 is like 2.23 or something like that. So, yeah. 5 is not equal to 49. Pick 3 more numbers. And that goes to the viewers. So pick 3 random numbers, excluding 1, 2, 3, 4, and 5, and 7. It could be a 1-digit number, it could be a 2-digit, it could possibly be a 3-digit. Okay. So if you have chosen between 11 and 25, we're gonna do that. So I'm gonna pick a number between 11 and 25 myself. So 11, 14, 17. That's what I'm gonna go with. 11, 14, 17. So we're going to test that 11 squared plus 14 squared equals 17 squared. So, we all know that 17 squared is 289. But, if you're just learning about the square root stuff, let me know. Okay. 11 squared is 121. Plus 14 squared is 186. 121 plus 186. I think it will be a little more than 300. But I think that's that. 121 plus 196. Okay. It just gave me 317. That's a little higher. So, if you are in grade 9 or higher, if you have watched my lesson 1-2 video about non-square roots, what is the closest number of 317 to go for? 289 or 324? I'll just give you guys a moment to think about that. But for the rest of us, pick 3 more numbers. Oh yeah, and if you have any questions, feel free to comment down below. Okay. So, if you said 12, 15, 20, we're going to do that. $200 squared is 400. 400. 15 squared is 225. 12 squared is 144. So 144 plus 225, I think, is 369. Okay. So 369 is a little closer to 19 squared, because 19 squared is 361. Okay. We're done with this for now. But here are the average square roots. So, the square root of 5 is closer to 4 than to 9. So, it would be closer to 2. This is approximately equal to 18, because 317 is closer to 324 than to 89. And this will approximately be equal to 19. Done. Thanks for watching this video. Okay, so I put on this video so that you all can put in detail about the Pythagorean theorem. And we're also, we might take some notes too. So, let's begin.
Hey everyone, and welcome to this lesson on the Pythagorean theorem. So let's start off with a few key questions. What is the Pythagorean theorem? What are the properties of right triangles? And how can you use the Pythagorean?
Okay, so what is the Pythagorean? Okay, so you're gonna answer these in the comments, and I am going to check and see if you're correct or not. So, okay. I'm gonna need. Okay. So, what is the Pythagorean theorem? What are the properties of right triangles? And how can you use the Pythagorean theorem to solve problems? You don't have to answer them now, but you're just going to answer them while we go over the video.
Theorem to solve problems. So let's go ahead and explore those questions and then take a look at a bunch of practice problems. Okay, so let's touch on a little bit of math history here. The Pythagorean theorem is named after an ancient Greek philosopher and mathematician named Pythagoras. And Pythagoras discovered that in any right triangle, where the two shorter sides, also known as legs, with lengths A and B, and the third longest side, the side that is directly opposite the right angle in the right triangle, and this longest side is known as the hypotenuse of the right triangle and has a length of C.
Okay, so we use this on our video. So it doesn't matter where you put the legs, it just needs to be a current. So if you could do this A, this B, this C, or this B, this A, this C. It doesn't matter.
Relationship is always true. A squared plus B squared is equal to C squared. So the sum of the squares of the two smaller sides is always equal to the square of the longest side. And
this is the formula. So A squared plus B squared equals C squared. That's the formula that you are going to learn. So Pythagorean theorem only applies to right angles. Right triangles.
just make an important note that this
It is not used for obtuse or acute
Now
triangles.
let's go ahead and quickly explore the properties of right triangles a little bit further, and then we'll learn how to use the Pythagorean theorem to solve problems. So before we move on to any practice problems, let's make sure that we really understand the properties of right triangles. 90 degrees. And you'll see in these three triangles how it makes that L shape. And that little box represents the right angle.
Okay, so a right triangle has one right angle equal to 190 degrees. The rest of the angles, I'm guessing they're 45 degrees. It doesn't matter about there's one right angle.
Next, let's talk about the longest side of a right triangle. This side of the triangle is called the hypotenuse, and it is always located directly opposite the right angle. And in this lesson, we are going to represent the length of the longest side of the right triangle, the hypotenuse. Now that you understand how to identify the longest side of a right triangle, the hypotenuse, let's talk about the two shorter sides of a right triangle. These are called the legs of the right triangle, and we represent their lengths with the letters A and B. Now,
Okay, so some teachers do A's called leg 1 and B's called leg 2, but the hypotenuse is not a leg at all. Legs are lines that are not diagonal, so.
No, we don't do that shit.
So, the pink one is A, the bottom, the blue one is B, the green is the hypotenuse.
final note on the legs of a right triangle. The hypotenuse C will always be directly opposite the right angle. If A and B are interchangeable, so it doesn't actually matter which one you label A and which one you label B, as long as you only are labeling the legs of the right triangle and not the hypotenuse.
Yes,
This is very important.
that's true.
Doing this correctly will allow you to use the Pythagorean theorem to solve examples. And now we're ready to go ahead and take a look at a few of those examples. Okay, so now that you understand the properties of right triangles and what A, B, and C represent, you can now start using the Pythagorean theorem. And again, the Pythagorean theorem states that for any right triangle, A squared plus B squared equals C squared, where A and B represent the lengths of the legs of the right triangle, and C represents the length of the hypotenuse, the longest side that is directly opposite the right angle. So for this example, let's go ahead and label A, B, and C. So we know again that C is the hypotenuse, the longest side. So in this example, C is equal to 5. Again, since that side is directly opposite the right angle. Next, we can take a look at the legs to find the values of A and B. Again, these are the two shorter sides of the right triangle. And in this example, we have A equals 3 and B equals 4. And again, you could have done that the opposite, where B equals 3 and A equals.
Okay, so we did an example of this. So you can know which one is A or which one is B by just thinking about it in your brains. So for me, I would put the shortest number B and the longest number A. So in this case, I would have put 4 for here and 3 for here. So in this equation, we would put 4 plus 3 equals whatever number that is.
Equals 4 doesn't matter as long as you correctly identify C. So now that we have values for A, B, and C, we can plug them into the Pythagorean theorem. And if it works out, then we can conclude that this triangle is indeed a right triangle. So let's go ahead and see if it does work out. So instead of A squared plus B squared equals C squared, we have 3 squared plus 4 squared equals 5 squared. And we want to see if that's true.
Yeah, we want to see if these are equal to this number. So, you know your squares and square roots very well. So, I think you can do this easy peasy, lemon squeezy, like I did. Let's get going.
So let's go ahead and work this out. 3 squared we know is equal to 9. Plus 4 squared, which we know is equal to 16. And now on the other side of the equal sign, we have 5 squared, which we know is equal to 25. So now let's go back to the left side. 9 plus 16 we know is equal to 25. And of course, it is true that 25 equals 25.
Okay, so here's what I would do. Instead of having 3 squared plus 4 squared equals 5 squared, I would do 4 squared plus 3 squared equals 5 squared. Yeah, 16 plus 9 is equal to 25. Okay? And now, what he did is that he added both of the numbers together and made it combine. So, 9 plus 16 is 25. Well, is 25 equal to 25? Yes, it is.
So because this worked out, and we just showed that a squared plus b squared does equal c squared, we can conclude that this triangle is indeed a right triangle. So this example really showed you how the Pythagorean theorem works. And now that you have a better understanding of how it works, and now that you have a little bit of experience, let's go ahead and look at some problems where we use the Pythagorean theorem to find a missing side of a right triangle. Okay, so here's our first practice problem where we have to find the missing length of a right triangle. And again, since this problem involves the lengths of a right triangle, we can use the Pythagorean theorem to solve it.
Okay, so we could tell that a squared plus b squared equals c squared. So I'm going to put 12 squared plus 5 squared equals c squared. I'm just going to put it down here. So, yes, as you see, I have an Xbox. And my Xbox, for me, is for clocks and stuff like that. So, yes, I also watch some of my videos, too. So, 5 squared, 12 squared plus 5 squared equals c squared.
So just like the last example, let's start off by identifying which side is the hypotenuse. And again, we just label that C, and that is the side directly opposite the right angle. And in this example, we don't know the value of C. It's denoted with a question mark. So we're just going to leave C as is, as the letter C. That's what we have to solve for. We want to find the value of C. Next, we can label A and B the lengths of the right triangle. In this case, we'll call A 5 and B 12. And then we can go ahead and substitute 5 for A. And
okay, what I did is I substituted A for 12, B for 5. You can do whatever you want. So, you could do 5 squared plus 12 squared equals c squared. You could do 12 squared plus 5 squared equals c squared. You don't have to choose. You could just write it down.
12 for B. And now we're ready to use the Pythagorean theorem. So again, instead of a squared plus b squared equals c squared, we have 5 squared plus 12 squared equals c squared. And again, the reason why c is a letter and not a number is because that is the side length that we don't know. And that is what we're trying to figure out, what number C actually represents. And now let's just go ahead and work this out. So 5 squared, we know, is equal to 25. Plus 12 squared, we know, is equal to 144. And that sum is equal to c squared. We're just going to bring that down. Now, back to the left side, 25 plus 144 equals 169. So now we have 169 is equal to c squared. So we are very close to finding the value of c, but we just want c by itself. We don't want the exponent attached to it. So we have to perform inverse operations. Now the inverse, or opposite, of squaring a number is to take the square root of that number. So in order to get c by itself, we have to take the square root of both sides of the equal sign, both sides of the equation. So when we take the square root of c squared, we are left with just c. And again, the whole reason why we took the square root of both sides is to get c by itself. Now over on the left side, the square root of 169 is equal to 13.
Okay. Yes. I know. So what I did, I swapped these around. I got 12 squared plus 5 squared equals c squared for this. And then there's a step below. 144 plus 25. This is equal to 144. That's equal to 25. That's equal to c squared. And then I took the square. And then this is what I got. 13 equals c. That is how you do the first problem.
And we can conclude that the value of c is 13. So we just figured out, using the Pythagorean theorem, the length of the missing side, in this case the hypotenuse of the right triangle. So if you're still feeling a little bit confused, you might want to go back and work through that problem again. But if not, let's go ahead and move on to a second practice problem. Okay, so now let's take on practice problem number 2. It's pretty similar to the last example. We have to find the missing length of a right triangle. 2 of the side lengths are given, and one of them is denoted with a question mark. That's the side that we have to figure out the value of. And again, we're going to use the Pythagorean theorem to do that. So just like the last example, let's start off by identifying which side is the hypotenuse and label that with c. So again, just go straight across, opposite from the right angle, and we'll label that side length c. In this case, c is equal to 10. Next, we can label the shorter sides of the right triangle, the legs, with a and b. So in this example, we can say that a is 8, and b is our unknown value. That's our question mark, the value that we have to figure out. So we're just going to leave that as the letter b. Now that we know a, b, and c, we can plug those values into the Pythagorean theorem and solve. So in this case, we have 8 squared plus b squared equals 10 squared. And again, b is a letter, not a number in this case, because we don't know the value of b. That's the value that we have to find. So now let's go ahead and work this out. Starting with 8 squared, which we know is equal to 64, plus b squared. We don't know what b squared is, so we're just going to bring it down to the next step of our equation. And we know that that sum is equal to 10 squared, which we know equals 100. Now, we need to get b squared by itself. And to do that, we have to get rid of that 64. And that can be accomplished by performing inverse operations. The opposite of a positive 64 is a negative 64. So we can subtract 64 from both sides. So on the left side, 64 minus 64 is just equal to 0. So those go away. And on the right side of the equation, 100 minus 64 is equal to 36. So now we are left with b squared equals 36. And now, just like the last example, we are very close to finding the value of b, but we just want b by itself. So we have to get rid of that exponent. And to do that, we do inverse operations by taking the square root of both sides of the equation. Because again, the inverse of squaring a number is to take the square root of that number. So the square root of b squared is just equal to b, and the square root of 36 36, we know is equal to 6. So we can conclude that the value of b is 6. So the length of the missing side in this example is 6. So again, we just used the Pythagorean theorem. We were given two sides of a right triangle and one side was missing to find that missing side. So hopefully you're starting to get the hang of this a little bit, but let's go ahead and take a look at one more example. Okay, so here's our third and final practice problem. Again, we have to find the missing length of the right triangle. And we're going to use the Pythagorean theorem to find that missing length. So the first thing that we will do is identify the hypotenuse and label it with C. In this example, we can see that the hypotenuse C is equal to 27. Next, we can label the legs, the two shorter sides of the right triangle, with A and B. And in this example, A is our unknown value, denoted with the question mark, so we're just going to leave it as A. And the length of B is 9, so we will replace B with 9 in the Pythagorean theorem. And now we are ready to solve. So in this case, we have A squared plus 9 squared is equal to 27 squared. And again, the letter A is not a number in this example, it's just the letter A because that is the missing side, the one that we have to find the value of. So now let's go ahead and solve. On the left side of the equal sign, we have A squared, which we just have to leave as A squared, plus 9 squared, which we know is equal to 81. And that sum is equal to 27 squared, which equals 729. Now to isolate A squared, we have to get rid of that plus 81. We can do that by performing inverse operations and subtracting 81 from both sides. That gets rid of the 81 on the left side. And on the right side, 729 times 81 is equal to 648. And now we have A squared is equal to 648. So we have to get that A variable by itself, meaning we have to get rid of that exponent. So the inverse operation of squaring a number, again, is to take the square root. So we'll take the square root of both sides of the equation. The square root of A squared just equals A. And the square root of 648 is going to equal a decimal. So in this case, we can say 25.4558, and that decimal continues on.
Did you get Brent?
And
Get
you
your ass
can round
back
that
here.
number any way you like, 25 nearest 10, or 25.46
Wash your
if
hair
you're
and get
going to the
finished.
nearest 100th decimal place. Just know that it's okay to have a decimal as an answer,
I
and it's
said
actually
there's a
very
towel in there in
common
the
with
fucking
Pythagorean
rack.
theorem questions.
On the
So
toilet.
that's it for our practice problems. I'm going to leave you with one last problem you can try on your own, and you can share your answer and try it out and see if it works out, again, using the Pythagorean theorem. So thank you again so much for stopping by and for joining me on this one, and I'll see you next time.